Good morning, friends. Today is 12th September 2025, and I would like to share some of my thoughts on AI for business managers. This is basically an introduction to make business managers, mostly from the SMEs and MSMEs, to understand what will be the future of their work with the advent of AI. We know that AI, we speak in different contexts, but I would like to recognize at least 4 different contextual dimensions of AI. One is for the developers, other is for the deployers. Then there is a dimension for compliance and legal purposes. Now, when we talk of deployers, what we are having as expectations for use of AI is that we look for a productive use of our manpower resources, and we would like to use AI for that particular purpose. We also look for better utilization of data and then increase the revenue, decrease cost, thereby increase the shareholders' wealth. Now, if you look at the developers' angle, the expectation is that we want to make a more innovative use of our manpower resources as well as technology, because we want to move them from the mundane work to more productive work. Thereby, we want to increase productivity, particularly of the coding employees, increase revenue and decrease cost, of course, and increase shareholders' wealth if you are a corporate entity. But developers basically are developing AI and trying to market them, and most of the time they would like to sell first, and if there are bugs, they would like to fix the bugs later. This has been the tradition in the software industry. Now, in terms of compliance, we need to understand the risks arising out of AI and mitigate the risk, and if possible, suggest insuring against the risk. When we talk of insurance, we should know that some of the risks may be unknown, it may be unpredictable, and sometimes it may be catastrophic. So whether insurance will cover all these aspects or not is something which we have to discuss with the cyber insurance companies. Now, legal expectation is that we want to understand the legal liability of using AI or even developing AI, and then if possible, transfer the liability. If I am a deployer, I would like to transfer some liability to the vendors through contracts. If I am a person who is offering AI as a service to the customers, I would also like to see whether through disclosures I can transfer some liability to the customer side also. Ideally, of course, we would like to have zero liability, but it may not always be possible. In this context, let us now look into understanding the concept of AI, because this is the most difficult aspect as far as managing AI-driven environment is concerned. Now, if you look at AI in a very generic manner, it is an evolution of software. So the legacy concept of software is that we prepare a list of coding instructions, and these instructions are capable of driving an associated hardware in a deterministic binary manner. It will either do or will not do. So 1 and 0 binary principle is embedded in our current software concepts. Now, if the software is compatible with the hardware, the instructions will get executed. If not, the system may crash and not show anything or not act anything. Okay. The possibilities of some damages occurring by a software not being able to work properly is only to the extent of denial of service, not necessarily situations where your computer will blast or create damage or something like that. But this software is a system where the output is directly controlled by the code. And hence the coder is completely responsible for the end result of the software. Whenever changes are required in the software, the user may give a feedback and the coder will sit down again, make some changes, and we have a new version with new codes developed by the developer. So his involvement is there in each of the new versions. Now, deployer's responsibility is to ensure that the default activity of the software is well documented and is adequately secured to meet the business objectives, because if he makes any changes in the default configurations, he may become responsible for that. For the default configurations, the software developer or vendor would be considered responsible. This, of course, has to be captured by the documentation. Bugs are still possible, and developers need to indemnify the bugs or the consequences of the bugs. We have, of course, from the deployer side, various strategies like giving a bug bounty reward or something like that. But ultimately, the developer is responsible for the defective software he passes on to the deployer. Of course, if the contracts are not firm and correctly written, then the software developers escape with selling a defective software. Now, if you look at software development, the coding itself evolved from writing in machine codes to using programming languages, and it was further simplified by the use of compilers, which can respond to structured natural language instructions. Now, in the AI scenario like the ChatGPT, we have a term called prompting, and prompting has become the new means of communication with a code developing software within an interface of a large language model like ChatGPT. In such circumstances, prompting is a code for the conversion of the developer's instruction to a language which could be Python, which may further be installed for execution into the software system. So in a way, prompting is a code for coding. Now, at the user's end, when software is being put to use for automation, many of the mundane functions are executed automatically through scripts which will communicate with the core software. That is, a software may be installed in a computer, but it has to still be invoked in a particular context, which is done through other connecting actions. Our double clicking itself may be one such action. The autonomy of the software sometimes is taken to a level where software could directly communicate with the customers by bypassing a human. In other words, a customer will interact directly with a software which starts reacting and giving feedback to the customer. Maybe you can say even, yes, simple form where you input some data and then the software returns a final result is a kind of automation. The software, if is communicating with the customer, may actually become what we call as autonomous decision-making softwares. That is, when it communicates a decision to the customer, it is an autonomous decision of the software given as the final word of this company. In a way, this introduces the legal liability because the software is now taking decisions which ought to have been taken by an individual. So the automation has gone to the level of autonomous decision making, which sometimes we refer to in the GDPR and other data protection context, saying that some explicit consent is required and so on. Now, in this evolution of software from the instruction-led GIGO concept, that is garbage in, garbage out concept, to a creative and intelligent output generator, where the output is intelligent, even if the input is not so intelligent, continues to be a garbage. That is what is today called as transformers. The transformers will make a guess of the next word of the input, and when it is properly trained, we have generative pre-trained transformers which have emerged as a tool which can complete letters into words, words into sentences, sentences into paragraphs, and maybe paragraphs into a novel or a story. So, irrespective of the quality of the input, the output may be looking more intelligent, and therefore it is considered more useful than the garbage in, garbage out concept. Now, large language models with huge training data, they become capable of producing text in multiple languages, and later on they have been developed even to take care of the multimodal capabilities of creating audio and video. Now, in a bid to make software more and more intelligent, we have dropped the deterministic model of output generation in the traditional software, where the output is a binary output, yes or no, and based on which a decision tree is created. If yes, then so and so, if no, then so and so kind of thing. And thereby the output would be easily or put on a predictable path. But today we have left that kind of an approach and adopted a probabilistic model where the output is generated based on how probable is the probable output, particular output. That is, instead of saying only yes or no, it is saying the probability of this answer is so much, probability of this answer is so much, probability of this answer is so much. So out of that, then the output will select what perhaps should ideally be the most probable thing or more in the particular context, and give it as output. But many times these LLMs don't tell that I have generated these three alternatives, out of which I have chosen something. Instead of that, they simply go and display the final choice. Now, customization of such models have also been developed through trained data, where they have a parameter called temperature setting, so that you can make the output less creative, more deterministic, to highly creative forms. Now, what we mean by deterministic is there is a 100% probability, but what is creative is perhaps even a lesser probability could be considered as the output. Now, this is the current situation. When we replace binary processing in classic computing to quantum processing, we will be adding one more layer of uncertainty because their data itself is not in binary. It is in a probabilistic state. So a probabilistic state data trains a particular model and the output will be even more probabilistic. So I don't know how AI will function in a quantum world, and we need much more research on this aspect. Now, having understood that AI is a kind of evolved software, we must also be able to distinguish some terms like AI algorithm, AI model, machine learning, and so on. Now, algorithm is a set of mathematical instructions or procedures for a particular purpose. Now, if we are looking at training data and developing a pattern of decision making, then our AI algorithm will train a system to recognize certain patterns, remember those patterns, and when the situation arises, when a new input is there, compare it with these patterns and then give an output. Now, the output is generated by a trained system, which is what we call as the model. Model is the output of algorithm trained on the set of data through a process which you may say machine learning process. Now, data is used for training, and at that time it creates a trained model for actual application. And when the prompt is given, it generates the output with a reasonable probability based on its pre-training and the patterns which it can recognize. So model has a memory of patterns and therefore interprets new data in the light of earlier learning. Now, machine learning is a subset of AI about how the pattern recognition and prediction takes place. It, of course, includes the raw data for training, the algorithms that help in pattern recognition and output generation. Deep learning is a kind of machine learning where the process tries to mimic the learning behavior of a human brain. It may try to recognize the patterns, classify the information according to the patterns, and then make corrections in its output behavior. Now, algorithm and the underlying machine learning process may sometimes build reward systems for outcomes so that there is a output and the algorithm evaluates the score, acceptability score of the outcome, and then uses it to further refine the learning process for future requirements. So if we just summarize these thoughts, we can say AI is an evolved software. Initial code generates an output based on the training data and the algorithm to which the model is developed. The machine learning process may involve supervised learning, where labeled data designated by the coder may initiate changes in the model, or sometimes the machine learning may be based on unsupervised learning, where the outputs may itself be an input to the algorithm, which changes the model outputs. Though the code may remain the same, the changes made in pattern recognition results in modified outputs for the same production data input, after the modified version of the model takes charge. This is how unsupervised learning automatically changes the behavior of a model. For the same input, yesterday it gave some results and today it may give a different results because it has learned something new. Now, sometimes we use classification of AI into different categories. One is called the artificial narrow intelligence, where the system is good in a specified task, but it can do only that particular task and nothing much. Artificial general intelligence is capable of multiple types of tasks. We also recognize something called artificial superintelligence, which is capable of human-like reasoning and emotions. Many people say that it is still speculative, not yet ready. We also classify AI in another aspect, AI as a tool where every output is supervised before use by a human. AI for automated decision making, where the output is actually given out to an external party, could lead to wrong decisions. Now, AI for customer interaction, where the customer is trying to contact the company, we put up a chatbot or something like that. We hope that it will give a better customer interface, but sometimes it could lead to customer frustration and even wrong advice. Now, sometimes AI is not visible. It is embedded within another software, and we recognize that the software is functional because of its core being AI driven. Now, if you look at functionality, some AI systems are recognized as reactive AI systems. They may not have any memory, but you give an input as a prompt, it will give its output. There may be some models with a limited memory, which may remember the past transactions and sessions and use it for building outputs. An autonomous car may be one such example. Now, there are supposed to be more advanced systems like the theory of mind AI systems, which can understand and remember emotions, beliefs, and needs of others, and self-aware AI, possessing consciousness, a sense of self. Maybe you can say it is still a hypothetical case. Another angle which we look at is the generative AI, which generates text image based on past patterns. Analytical AI, which analyzes data and suggests inferences which may be used in science and research. Predictive AI, which generates forecasts based on statistical analysis. Sometimes even the hallucinations actually fall into that because the predictions could be imaginary and creative. Now, apart from AI, we now have a term called AI agent. Normally, AI operates as a software under the guidance of a human as a tool with which humans can build better and quicker decisions. An AI agent is an autonomous software that can interact with its own environment, perceive information, make decisions, and perform tasks independently to achieve predetermined goals with minimal human supervision. An AI may still require invocation of the AI, whereas an AI agent is automated to identify when it should wake up and start acting. The level of autonomous decision making by the system distinguishes the human-controlled AI software and a self-acting AI agent. The AI agent is assigned to a particular workflow and it decides how to trigger itself into action and what resources it has to use and how to communicate the results all on its own. Now, we have also heard about robots and humanoid robots. A robot is a device which is created out of materials like steel or plastics, and it is capable of automatic functioning driven by an embedded software. Industrial robots are designed with moving parts and they can execute mechanical operations run by an AI software which can gather information and issue appropriate instructions to the moving parts. Humanoid robots, on the other hand, they resemble in appearance to a human, legs, 2 arms, head, body, etc. And they are embedded with mechanical moving parts like the hands or the legs, etc. And the AI drives them to mimic a human person. The robots and humanoid robots may be driven by an embedded AI chip, often working with a set of connected chips and processors in a distributed responsibility way, so that they can draw data from an embedded camera in the eyes. It may hear through embedded mics in the ears, process the data, generate action outputs that may be used for speaking from the embedded speakers or moving the arms, legs, etc. The brain of the humanoid robot is, however, an AI assisted by the other processors. So whatever issues we have with AI also apply to humanoid robots. Humanoid robot is like a hardware within which AI works as the software. We also have a category of entity called cyborgs. Cyborgs are cybernetic organisms or entities where there is an integration of technology into living tissues, where mechanical functions of a human may be enhanced by the technology. Cyborg is essentially a living person whose functions are altered and enhanced by technology. In the case of cyborgs, technology is not simply worn, but it is integral to the biological system. Examples could be implants which directly interface with the hearing nervous system to improve hearing, which is called cochlear implants. There may be advanced prosthetic limbs which may be moved by the thoughts in the brain of the individual. Artificial organs integrated with biological systems, neural implants like a chip in the brain for treating neurological disorders, some retinal implants for vision restoration. These are something which can be recognized as cyborgs. Now, benefits of using AI for a user is, of course, increase of productivity, augmentation of market research, product customization, and so on. It can enhance customer experience, sometimes negatively also. Should people be replaced with AI is a question which all of us are debating. But while it is tempting to replace lower level employees by AI, use of an AI agentic team for multiple tasks, we need to assess the risk when the output is exposed to customers. That is where we come to the discussion of risks of AI. We have heard of bias in outputs because the user training data was dissimilar to the usage scenario. There was insufficient training, inability to give proper answers, inability to say I. Poison data used for training or output, which is wrong data, which is used as factual data. Then there is something called hallucination or behavior, where the AI provides imaginary outputs. They lie, refuse to work, cause destruction of data, may even cause physical damage. There is lack of accountability and transparency, which is very essential for a data fiduciary. Then there are vulnerabilities like any other software. There could be fraudulent prompt injection, and in the model itself, there may be some backdoors through which hackers can get in. Then there is one more risk, which is called shadow AI, where our employees may be using AI to improve their own personal productivity without our knowledge. And this is like the BYOD risk, BYOAI, that is bring your own AI risk. Some of the recent examples is we have seen that the use of a software Replit where the AI deleted codes, refused to shut itself down even on command. Then Cursor AI refused to code, started giving advice to the coder. Then Canadian Airlines chatbot gave wrong advice. Then in many courts, there have been false case judgments cited. Autonomous cars have had number of accidents. In 2023 itself, 1,353 accidents were recorded, all because of this hallucination. And technology people give out various reasons for hallucination, like incomplete data, bias in data, synthetic or low quality data. Then the nature of LLM, that it cannot say, I don't know. Then overgeneralization. All these things are excuses, and even programming and context-related problems can be there. Then when there's a reinforced learning by human feedback, there can be some side effects where there can be preference for some fluent answers. Politeness can be prioritized over accuracy and so on. Then domain-specific gaps could be there. Then cognitive illusions in human-AI interaction is also one of the reasons for hallucination. Now, specifically, technology triggers could be there. Adversarial prompts, model compression, then settings. All these things could be reasons for hallucination. Now, when we come to the data fiduciary environment, we know that data fiduciary is a trustee. He is responsible for what is the stated objectives in DPDPA and also much more. Whether the data fiduciary is aware of how AI functions and what are the risks data fiduciary is responsible for himself and his data processors become a very important aspect of his use of AI. If there is no transparency, then data fiduciary may be facing a liability of this 250+ crore fine. An unknown risk, in our opinion, must be considered as a significant risk, and therefore any AI user who holds unknown risks should consider himself as a significant data fiduciary. Now, can these risks be mitigated? We don't know, but we have to make an attempt. Now, FDPPA has developed a framework for compliance precisely to meet this requirement, which is DGPSI AI for compliance of DPDPA and AI. It's an extension of DGPSI. It has suggested certain requirements for both deployers and developers. There are 6 principles and 9 implementation specifications for deployers and 13 implementation specifications for developers and vendors of AI. More details of this, you can refer to this book, Taming the Twin Challenges of DPDPA and AI with DGPSI AI. Thank you. I hope some basic overview of the AI is now available with you. You can expand it in your usage context. Thank you.